Okay, sorry. So now we have the character comes out in plan by default, so I don't want to deviate from the tutorial, and when we record this you'll have it. So with character you can do lock character, and now when we select the object it's like selecting the group. And we don't have to worry about selecting each plane by accident. And the tutorial calls it, I think, CO1. So to stay true to that, we'll also call it CO1. Next, let's make a point, which you go over here and making your dummy objects. Create a point, and there's lots of different ways you can display it, and you can control the size, but it's just a dummy object that we're controlling. So what we need to do to this character now, though, is apply a modifier that's called attribute holder. And it's just a blank modifier that we can then start to put our own custom attributes on. And we'll put one on the point as well. Attribute holder. And you bring up over here an animation in your parameter editor. You can also get to it by hitting Alt-1. I'm going to put a parameter on the point called range, which we're going to use to govern the range of this point's effect. And we'll just do 0 to 500 arbitrarily. You can get a sense of what it's doing here. We'll call it range. That's what it's going to look like. And selected object's current modifier, that's what it's going to put it on. So when I hit add, there it is. We've got our own custom parameter. So that's quick. And right now it's not tied to anything. It's not doing anything. That's a way to start to make our own parameters on objects. So now here on the character, we're going to put another parameter. Just hit Alt-1. But this time we actually have to pick where we're going to want it, since it's got a few things going on here. We'll do pick track, object, character, modified objects, attribute holder. We want to go on that modifier. Let me double check. Yeah. And we want this one to be called distance. So it's going to store the distance between the object, the character object, and the point. And it's just really going to be a factor for us to control the opening. So we're going to control the distance from a value of 0 to 1. It's going to be a multiplier, really. And we'll default it to 0. We'll do add. Ah, shoot. Didn't. Well, I don't have anything selected. That's why I didn't. But there it is. I put it on because I already picked the track. I put it, and actually range, I want to default to 100. So we have this. Doesn't do anything just yet. Just goes from 0 to 1. So what we need to do now is put a controller on this distance so it actually knows to understand that. There's a couple different ways we can do it. The easiest way is to just right click on here and do show and track view. Hey, there it is. What? Alright, I guess I can't move it. It'll be a little tricky, but we want to assign a controller to it. So if I right click on here and go to assign controller, I want to do a float expression. So this is similar to expressions in Maya, if any of you have used them. The interface is a little clunkier than Maya, I think, but once you start to play around with them, they make a little sense. So we need to state some variables that we're going to run our formulas with. So the first variable we're going to create is range, and it's going to be a scalar variable. It's going to be one number, and we'll create that. The next one is going to be character or char POS position, and that's going to be a vector because it's going to store all 3 coordinates. We'll create that, and then we'll do point POS. That's going to be a vector also, and we'll create it. And all that stuff is in this written PDF, so don't worry about catching all this stuff too closely. So now it's writing out, well, we also need to assign these variables to things now, because right now it's just an empty variable. It's not connected to anything. So one of the nice things about these expressions is that we can assign them to things in the scene. So if we go over here, assign to controller, on my objects, on point, range, so now that variable equals whatever is in that input box. Character position will assign to controller. So character, transform, position. And notice I'm selecting position, the vector, not x, y, and z. So that's why it had to be a vector variable. And for the point, we'll do the same thing. Position. So what we're going to use now as a function in these expressions, what will give you the length between two vectors. And if you want to see all the available functions are here, when you hit function, what we're going to use is length. So we'll do length. And it's going to be character position minus the point position divided by the range. Because otherwise it gets way too big too fast. So we'll evaluate it. It's now stored. The problem is these things aren't really tied to anything. But the way you'll be able to see it now is, see the distance is 0.67. If I move this thing, distance is now 0.84. Storing that vector, or the difference between those two vectors. So now what we want to do is attach that distance to the rotation of each one of these panels. That's how we're going to get that varying opening. So we'll go back to our track view, which you can get to by hitting this button right here. See that? Or actually, no, what we want to do, sorry, is use wire parameters now. We want to wire the rotation to the distance. We can bring up the wire parameter dialog box and find them manually, or it's easier if we just right click on here and go to, oh, it doesn't want to do it. So we'll have to bring up the wire parameter, or right click on here and go to wire parameters. It brings it up. So we want to wire distance to, see the character has a separate little plus here. That's to the objects inside the character. So here's our lines inside of there. So we'll start with line 04, transforms, rotation, X rotation. And we want the distance to drive the rotation. And we'll do connect. Well, it's their local rotation. So since it was made in one way and then I rotated it each way, it's always the X on each one of those individual planes. Is that what you mean? Yeah, I mean, which side? Yeah, since it was made on the X, it's always on the X. So let's just test this thing and see if it's working. So yeah, there it goes. That part's working. And this is in radians, and we want it in degrees. So there's a formula in here that I forget. So we'll take distance times DEG to RAD. And this is to top it out at 60 degrees. Update. So now that's working. I'm going to copy that because it's going to be the same for all the other ones. And while I have this interface open, I can just link them all real fast. So rotation, X rotation. Paste that in, connect it. You can see they're jumping over here. X rotation, paste it again. So now when I move that point, it opens them all. And that's all tied through the expression controllers and the wire parameters. The tricky thing about expression controllers, and I just posted something on one of the forums today to try to find out a way to globally change them, but at this point I don't know of a way to change them all at once. once we array this thing. But we can go to the character and still affect the parameters on it, or the expression controller. But you can see it can open too far, and we want to limit this. So if I right click on here and go to show and track view, it takes me right to it, and I can go to the properties of it. Another function is this minimum function. So I go min, all that, and with a maximum of 1 of the distance. We don't want it to go past 1. So evaluate, and now it stops, which is essentially 60 degrees, because we put that in the other formula. We'd have to affect the wire parameters one by one. So we want distance and what distance is connected to. If I hit this little binocular, it finds it. So here it's, let's see if I do 90, if I do update, see that one can max out at 90 now. We'll leave it at 60. So now what we can do is we can array this thing. Once we have it working properly on one, and we want to do copies, not instances. Snapping and max is really getting to me lately. On. So now you can affect that series. And this range now drives the area of influence on that point, since it's in the formula. So that's what that's doing. You can move this around.